So you should see their course, that OpenShift Administration 2, Operating Architecture, Kubernetes Cluster. Okay. Hope everybody is able to download the book.
1 minute, Abdul. I have just now logged in. Could you please tell me once again? I should go to the dashboard, right? Or
yes, yeah. Go to the home.
Dashboard.
Go down. Yeah, you'll find the resources. In the resources, you find download ebook. If you click this, it will show you the options to like language option.
1 minute.
Select
You gone to the home, right? Home and then the resource.
yeah. In the home, you will find you're finding my virtual training classes, right?
1 minute, I'll check.
Yeah. Then join class. Then join.
No, nothing is there. Everything is blank here. My progress, my skill path.
You're not finding my virtual training classes.
No.
Okay. Which email? Which are you using this same ID? Here, that is Priya Jain. Like, are you using this one? Are you using this plus one?
I can hear.
Which ID you are using?
I actually do IDs and check.
So you have to use this specifically this ID, so that you should able to see. If you use other IDs, in that case it will not show you. So try this ID. Here. So you can completely log out, and so that means you can completely close the browser, and once again you open that link. In that case, you're opening the next time. What you can do is you can use your this ID. So here, this ID you can use to log in and check whether you are able to see that. Okay. So about others, like I think others are able to download the ebook. So can you please confirm me that you have downloaded the ebook?
Yes, sir.
Yeah.
Yes.
Okay. Thank you.
Yes, I have downloaded.
Yeah. Okay, you can just update me in the chat. So that's fine. Are you using this plus one? So just update me in the chat. It's fine. So. Okay. I think except Priya, others are able to. So Priya, what about you? You can able to log in? So when you use this one, you are able to see it?
Yes, I'm using it.
Hello? Priya, are you there?
Yes, I can hear.
Your voice is breaking. I can't. Yeah, okay. I think you're able to see the course. So you can find join resource, right? Priya, are you hearing me?
Yes. I clicked on join.
Yeah. So
So,
the homepage here, I
yeah,
think you are able to see me. See that.
yeah,
My
I
training
got the option to
classes.
download the ebook.
Yes. Download that ebook. So once this ebook will be like this, so it will be totally 356 pages, and you should be able to see. Once you download it, just continue with it. Then we'll start the course. So hope everybody is able to do that. Now we'll move on to the course. Okay. So let me have a small introduction about the course. So this course is DO280, which is Red Hat OpenShift Administration 2, and this is operating a production Kubernetes cluster. So this course is primarily about the day 2 operation, or you can say day 3 operation, where the cluster is almost installed, and you are going to work around start with the cluster settings, or start with the cluster operational things. So specifically here, so we are not going in depth of the installation. So actually installation is has been separately covered in a separate course, so like the hands-on level. So here it will be like operational perspective. So how we are going to operate the cluster. Once the cluster is installed and ready, so that's handed over to the operational team. So how they are going to start working with the cluster. So that is the main things we are going to cover in this course. So here we'll see about the course summaries that you will be seeing about OpenShift container platform. So here we'll see the description in descriptive way how the installations are happening. So how the update process is happening, and we'll see about troubleshooting, mostly like troubleshooting issues. We'll see about how to configure users and authentication, and then we'll be seeing about how to use a role-based access control. Then how to securely expose the application to the external world, and how to use the network policies, how to use how to do the scheduling using the labels and selectors. We'll seeing about resource constraints, how you can do the resource constraints using the resource quotas and limit ranges. And we'll be seeing about managing the application using the web consoles, how you manage working with web consoles. And we'll see about a concept called operators. So we'll see how to install Kubernetes operators with the web console. So we'll be seeing around that. So about myself, this is the course introduction. So about myself, my name is Abdul. So I'll be instructor for this course during these 3 days. So I do teach OpenShift and OpenShift at different streams like OpenShift development and OpenShift administration. And I do teach Ansible, so Ansible basics and Ansible advanced levels. I do have production experience around 5 years. So I was working on as a telecom engineer for the production side. And this is my brief introduction. So, okay, and so we'll start now with the course. So I think everybody is able to download this book. So we'll start with the introduction. So we already seen about the summary of the course. So we'll see the course objective. So this course is mainly like how you know about installation, configure, manage, and troubleshoot the OpenShift cluster. So here the install basically like the install is not the hands-on level. Other things we'll be doing that at the hands-on level, like we'll be doing that at the lab. Installation alone we'll not be doing at the hands-on level. Installation we'll be studying about it. So what are the installation options are there? So how we can start with the installation. But hands-on level we're not able to do it because the installation requires more time. So for that reason, what they have done is they have moved OpenShift installation as a separate course itself. So if you want to know more about installation, you can go and opt for that course. So it is a 2 days course where they will be discussing about OpenShift installation. There you can do the hands-on installation. So here we'll see about just installation level. So we'll be seeing about the description, like descriptive way. So what are the installation options are there? And then, so this course is, you can see this course is Red Hat OpenShift Administration 2 and Administration 1, that is Red Hat OpenShift 1, which is the containers and Kubernetes. So together this, so you can able to take this exam, like Red Hat Certified Specialist in OpenShift Administration exam. And so the audience, target audience for this course are the software system architects, system admins, cluster operators, then SREs, site reliability engineers. So prerequisite for this course, or you can say it's not prerequisite in a sense, it is not like a mandatory requirement, but if you have this one, it is very easy to follow this course. Or you can say as an academic requirement for this to understand this course. So first is you should have completed either this one, which is DO280, which is about Red Hat OpenShift 1, which is containers and Kubernetes. That is a basic. So if you have done that, it will be fine. If you're not done that, if you have equivalent knowledge, so that will be sufficient. Like if you know what is containers, how to manage the life cycle of containers, if you know what is Docker. So even though we don't have a Docker here, but Docker will be the basics. If you know how to work around with the Docker, and how to do the basic container lifecycle management, how to create containers, how to start containers, how to manage containers, how to manage container images. So if you know that, that will be easy for this, to follow this course, because this is like a container management system. So here we are going to see OpenShift is actually a container management tool. So you can say orchestration tool. So here we'll not be discussing about the basic container level things. So here we'll be at a little bit higher level. So we'll see how the containers, how we are managing, we are going to manage the container at a very large scale. So how to deal with thousands of containers, how to manage it efficiently. So what are the basic principles of orchestration? So that will be we are seeing here in this course. And most of this course, like in this course, DO280, so it is going to be, you can say it is at the command line. So if you have RCSA, that will be better, or if you have equal knowledge, so if you are a Linux admin, so that will be better. So because most, like we have almost 8 chapters in this course. Out of 8 chapters, 7 chapters almost deal with command line. So we'll be dealing with working with the command line. So it is almost, if you have command line experience, that will be easy to follow this course. Okay. So then next is, I'll come back to this orientation to the classroom environment later on. Since starting, we are not going, this is about the lab environments, how to use the lab and this kind of things. So initially from the first chapter, so first chapter is just about description, like we are going to see about theoretically understand different principles. From the second chapter onwards, we'll go on with the lab. So during that time, I'll just explain you because otherwise I have to repeat the same information again. So I'll come back to this later. So since we are not going to the lab directly now. Next is how the teaching methodology will be. So how this course will be. So how this course will be presented to you. So I'll be following this and this study guide. So the course duration is very limited, like we have only 3 days. So I'll be entirely sticking to this study guide. So what are the concepts discussed over here? So we'll be discussing that concept. So we'll not go beyond that concept, since we will not have time to go beyond that, since the OpenShift has many streams, like OpenShift. Here we are going to just go through one of the streams or one of the part of that stream, which is OpenShift Administration 2. So we have a development stream, we have security stream, we have administration stream, and we have microservice development stream. So we have many domains on the OpenShift. So here we'll be covering out the administration, so basic foundational administration stream. So how to operate the production cluster. So how to operate the cluster with like as from the operational perspective. So what are the things we need to start with? So this is DO280. So this course will be followed by DO380. So administration 3 is there. So there is once you complete that, there is a security stream, DO425. So there are a lot of streams are there. So I will give references if you have additional things. So maybe you will find that in the advanced courses, maybe not here. And basic things like about the containers you will find in the DO280. So where you'll be studying about the containers. Because I don't know how many of you are familiar with that. Containers and these things. Maybe some of you may be entirely new to the containers itself. But that okay, so that we will so by the time just try to go through the basics about the containers, so because it is required to follow this course. So here it will be like a higher level of container management. So if you know about the container, that's fine. So just you need to know what is the container, how to manage the containers. If you know any one tool to manage the container, like Docker, so basic Docker tool, that will be sufficient to follow this course. So here, so we'll have chapters, and each chapter will have a goal, and this goals are converted as objectives. So these objectives will be covered through the sections. So we'll have different sections, one with respect to that objective, and with respect to the section, mostly this course is hands-on. So for example, if you go to this chapter, so here you'll find a section and followed by a guided exercise. The guided exercise is actually a guided lab. So you will have the steps for how to do the lab. So you will have a steps over here. So this is a guided lab will be there. You will be doing that lab during the class. So once I cover up that concept, I will provide you a sufficient time to do the lab, like 20 to 30 minutes, depending on the lab duration or lab length. So you can do that lab over here. And so if the concept is not hands-on, if it is just a descriptive view, or if it is a theoretical discussion, so you will have a quiz, so to cover up that concept. So whatever to test your understanding. So if you see the quiz, that means you are not having the hands-on. You are just it's about descriptive discussion. To understand, to test our understanding, you will have a quiz. So about that whatever the discussion we have made. So this will be our course things, and also in some chapters you have a lab. So this lab is actually a practice lab. So this will be like the exam format. Like you will have a question, so you will do that lab, and so you will grade your work. So as how it is graded in the exam. So that will be there will be a grading script. You will run that script to grade your work, so that you've done it correctly or not. And then there will be solution provided. So in case if you want to know what is the solution for that. So this is to prepare you for the exam. And this practice lab, so you will be doing that is after the class hours. So because it takes time, so you have to sit and revise the concepts, and you have to practice this. So we'll not have sufficient time during the class. So this lab, so end of the chapter lab, so you will be doing it after the class hours. So the lab will be available to you during these 3 days. The lab will be available to you 24/7. You can use the lab. So you can do this lab after the class hours. So the guided lab, I'll be trying to do this. You can do it in the class itself. So the lab, the practice lab, the end of the chapter lab, you can call. Can do it. That is after the class hours. So this is our teaching methodology. So how we are going to follow, you can say that teaching pattern. So we'll start now with the chapter 1. So during this one, I'll be swapping some sections. So swapping some section to some other day. Maybe I have to rearrange this things to just to suit the need of the requirement, like to give some priority to the technical content. So I'll be like swapping some sections. So anyhow, I'll cover this section at the end of the course. By the end of the course, I'll be covering all the sessions. But I need to swap some sessions. Maybe I will not be going in the order like this. So just to facilitate the fresh users, or can say the newcomers or beginners, to facilitate them, I'll be swapping some sessions. Swapping in a sense, I'll not be covering in this order. Okay. So anyhow, so we'll be covering everything together, but I'm not covering in the order. So as in the book, so I have to swap something. So I'll cover one thing first, and then the next thing later on. So just to facilitate the understanding for the new users. Okay, so here we'll start with the first chapter. In the first chapter, we have 3 different sections. So the first chapter is, the goal of the first chapter is to describe the architecture of OpenShift Container Platform. So this is the main goal of this chapter. And here to facilitate that, we have 3 different sections. So the first section is about describing the container platform features. So I'll be covering this one later on. At the end of the course, I'll be covering this session. This session is about OpenShift, what is OpenShift, and what are the different features of the OpenShift you can have. So here itself is we are going to, when you are starting. So here we'll see a lot of technical terms will be there. Maybe as a new user, that terms may not be familiar to you now. But once we are done with the course, so once we complete the course, that terms will be familiar to you, so that you will be able to understand the points in a better way. So for that reason, what I'm going to do is I'm going to skip this section. So skip this section in a sense. Now I'm not going to do this. This one I'll be doing that at the end of the course. This first section alone. Because it involves a lot of terminologies. So for the new users or beginners, so it will be like these terms may not be sound familiar to you. So for that reason, so once we cover up the major course contents, then I'll come back at the last and discuss about this one. So that case it will be familiar to you. So the concepts, because here we are going to see in a short form what we are going to see in an elaborated way in the later on. So that's better. You understand the concepts, then we'll come at this one. Then it will be easy to grasp that concept. For that reason, I'm skipping this first section. I'll go to the second section, which is very important one, describing the architecture of OpenShift. So this section is very important. I'll be going to this directly, describing the architecture of OpenShift. So this section has got different contents, like we have to discuss 4 different points. So like introducing the declarative architecture of Kubernetes, then we'll discuss about OpenShift control plane. We'll discuss about OpenShift, what is the extensions, then we'll discuss about the storage class. So 4 different points we have to discuss here. I'll start with this one, the second point, then I'll come back to this first one. Here I'm going to discuss about OpenShift control plane. So here it's just about control plane. I'll be discussing in an overall way. So what are the things required to build the architecture of OpenShift? So I'll discuss in the overall way so that it cover up that points together. So I'll be using this paint as my whiteboard to explain some concepts. So here what we are going to see is now about the architecture of OpenShift. So OpenShift is a tool actually, so which primarily dependent on the Kubernetes. So a heart of the OpenShift is Kubernetes. It is built around the Kubernetes. So OpenShift, so that because our course content itself can see operating a production ready Kubernetes cluster. So underneath the OpenShift, so we have the Kubernetes, that is heart. So that is a core actually, you can say. Without the Kubernetes, OpenShift is not there. So we need to understand how the Kubernetes architecture is built. So in case if you're new to Kubernetes, we need to understand what is the Kubernetes. And then on top of that, we'll see what is the OpenShift, because OpenShift is just a facilitation. It's going to give some out-of-box experience to the user with the Kubernetes. So directly when you use the Kubernetes, you will not have that experience. When you use the OpenShift, you have something out-of-box experience. Because out-of-box experience, in a sense, you will have some features directly available to you. In case if you are using the Kubernetes, that features will not be directly available. You can avail that features by just tweaking and twisting some configuration. You can do that, but the OpenShift, it is directly available, so that the user will save time to have that resource, and directly they can start working around that particular resource rather than configuring the resource. So we'll start with the Kubernetes architecture. So here we are going to have a cluster based architecture. So we are going to have something called a Kubernetes cluster. A Kubernetes cluster A cluster-based architecture, in a sense, you know what is a cluster is. A cluster is a combination of different mission units which act as a single unit to or a single functional unit to achieve a common goal. So you might have heard of HA cluster. You can say high availability cluster, or you might have a cluster for virtualization. You might have heard of virtualization cluster or storage cluster. So there are multiple ways the cluster can work. Similar to that, the Kubernetes operate in a clustered fashion. So here we are going to have a Kubernetes cluster which is going to facilitate the application deployment, and we are going to see orchestration tool, orchestration management. So we are going to see that. So the Kubernetes is a cluster-based architecture. So in the cluster, we have two different nodes. One is called a master node, or you can say this as a plane. You can say this as a control plane. So control plane. And we have other type of node called worker node. So please give your feedbacks, like if you're not hearing my voice, or if you see if you have any breaks in my voice, something. If you're sensing that, just give me a feedback so that we can adjust that. Since this class is completely virtual, so I don't have any clue what is happening at your end. So sometimes my screen sharing may get stopped due to some network disconnection or something. The screen sharing may stop. I may not be aware about that, so you can keep me informed about that. If you can give a feedback, it will be better to organize the class. Okay, so we have here the worker node. We call this worker node, or you can say compute plane. Okay. So when it's going to come to the cluster level things, so we are going to have multiple missions. Due to the lack of space, I'll not able to show you the multiple missions over here. So like the worker node, there will be more worker nodes. So worker nodes is a place where your application gets deployed. So there will be more worker nodes, 500,000. So you can multiple worker nodes will be there. And the master nodes also will be, for high availability, will have multiple nodes, but not as equal to the worker node, but it may be like a small number, like 3 or 5, 7, like that. The master node is the control node, so which is going to control the many worker nodes. So I might have multiple worker nodes. For the sake of simplicity, I'm just drawing another worker node. So the master node is going to take control of this worker nodes. Okay. So I may have multiple worker nodes in the cluster. So this is a cluster-based thing. So this is what we call a Kubernetes cluster. So which is going to have we can call this a Kubernetes cluster. Okay, and now we'll discuss some different components that make up the master as well as the worker nodes. So when we talk about the components at the server level, we know that, for example, when we have a system which is acting as a web server, so we have the web server service controlling that functionality. So the service running as a daemon which is controlling the functionality. Here on the containerization world, you have two different kinds of service. So at the server level, we have systemd based service. At the container level, we have service will be either running as a containerized service. Containerized service, in a sense, the service itself will be running as a container. So it will be running as a containerized service, or it may be like a normal systemd unit. It may be running as a systemd service. So systemd unit. Okay. So the first component, so on the master node, so the platform this OpenShift is a platform as a service. So any platform, you're going to have the base operating system. So the platform will be based on some operating system. Here, when you take the Kubernetes, the operating system, you can have any operating system independently. Any Linux-based operating system will be fine to deploy the Kubernetes. But here on the OpenShift side, so whatever the Kubernetes that is inside the OpenShift, that is going to use a particular operating system. So here we have a we will be using an operating system called RHEL Core OS. So that will be the base operating system for this master mission. So we call this RHEL Core OS. So this is a mandatory operating system that should be present on the master node. So when you have any master node, so that should mandatorily have this RHEL Core OS. Okay. So this is a separate OS. We have some features to this OS. We call this OS as Immutable OS. Immutable in a sense, you cannot do the performance tuning on this OS because a lot of things have been removed from this OS, so that to facilitate this OS just to serve for the containers, just to serve as a base for the container deployments. So a lot of performance tuning things have been removed, and this OS is made very lightweight. So a lot of it is not going to act like a normal RHEL OS. So a lot of things has been removed, and this is just completely optimized for the container deployment. So RHEL Core OS, you can able to specifically download separately or isolatedly. You can download this OS and you can work around this OS. And this is the OS is there inside the master node on the Kubernetes inside the OpenShift. So this is a RHEL Core OS. So to know about the feature of this OS is immutable. Immutable in a sense, you cannot do the performance tuning on this particular OS because that is not required. That's not the purpose of this OS. Normally, the performance tuning is required on a server level OS. So this is completely a containerized optimized OS. And next point is this facilitates the container platform. In a way, no need to worry about this OS once the OS is there. So actually, when you have server level OS, we need to do some kind of updates on this OS regularly. So we'll be doing some patching, kernel patching, system service patching. So we have to do that regularly. But when this core OS is there, this becomes an integral part of the system itself. So in a sense, like when you update the entire cluster, when there is any update for the OS, that will also be updated to that OS. So we need not worry about this OS after it is being installed. So we need not worry about system patching or kernel patching like that. So that is the main reason why we are going for this OS. And this OS is very lightweight, and a lot of things have been removed. And a lot of things runs as a container itself. So a lot of services, some like for example network services, so will be running as a container itself, containerized service itself in this OS. So this is the main features of this OS. You can read a lot about this. Can reduce the screen resolution? You cannot see properly. The screen resolution in the sense you are talking about the size or something. So how we want to reduce my screen resolution, like any suggestions?
I think no. 8,000.
Yes, 75, 50, 100. Mm-hmm. 15 are very small. 75 is not coming. 50, 100. Okay, so yeah. I think I cannot reduce more than this. solution. Anyhow, I'll share this one to you so that you can later on refer to this material in case you're not able to see it. Right, so RHEL Core OS is the base OS over here, and on the master node, this is a mandatory OS. You should have this on the master node. There is no option. Depending on the worker node, depending on the way of you are doing the installation, so you have the option to use two OS. One option is you can use the RHEL Core OS on the worker node, and other option is you can use the normal RHEL, Red Hat Enterprise Linux OS, greater than this version, so not below this version, so greater than the version 7.6. So it should be greater than 7.6. RHEL starting from RHEL 7.7 or RHEL 8. So you can use more than this because that supports some kind of container deployments. So below this, you cannot even use RHEL 7.6. More than 7.6, starting from 7.7, 8 like that. So you can have a choice. So this depends on how you are doing the installation. So how you are managing the installation. So we'll see later about installation option. In that case, you'll see you have a choice either to use RHEL Core OS or you can use a normal RHEL distribution. So you have a choice to use this OS. So this is the base about the OS, which is OS requirement for that master thing. Then we have something called component, very important component of the master. We can call this as API server. So Kubernetes, you can call this Kube API server, or you can simply call API server like that. So this is a API server. So normally you can call this as a Kube API server also, Kubernetes API server. So this Kube API server is the place where you are going to interact. So this is the server which is going to manage all the function. So manage the communication between the worker node and manage the deployment, manage all the things. So this is the server, and whatever your request, so whatever your request, you are going to give it to this API server. So whatever you are going to interact with this, your interaction will actually first come to this API server. So you will be using when you have if you have studied Kubernetes, you'll be using this kubectl command. The kubectl command. In the Openshift, we'll use something called OC command, Openshift client command. So later on we'll say about that. So OC command. So using that, you will be interacting with this. So you'll be interacting with this Kube API server. So Kube API server will do all the control function. So for example, whenever you want to create and deploy an application, your request will come to the Kube API server. The API server will forward your request to the concerned scheduler, and the scheduler will get that information from something called etcd. Then it will deploy the application. So this is the main contact point. This is the main control point, the Kube API server. And the next important thing is so once I say this API server, so the question will be how it is running. So this is running as a containerized service. That means it will be running as a container itself. So later on we'll say about a pod. So before I discuss about the pod, I'll use the term container. So it will run as a container itself. So containerized service. It will self run as a container service, and we'll call this as a static container. So later on we'll see what is a static container. So this will run as a static containerized service. So next important component on this master node is etcd. So etcd, actually it is a database. So there is a etcd database will be there. So if you look at what is etcd is, you can just go to the Google and you can search for etcd. Etcd is something like a database. So Kubernetes is adopting, it's an open source database. So Kubernetes is adopting this database. So for what it is adopting, this Kubernetes is adopting to store the information about the cluster. So we have discussed about the worker node and the master node like that. So how to keep a track of that? So I have thousands of worker nodes. So which worker node is running, which worker node is down, and so we have discussed about the different OSs on the machine, and we have different hardwares on that worker nodes. How to keep a track of that? That is through the etcd. So etcd will store this information. So this information will be essential now and then for that the next component which we'll be discussing to schedule the application. So where to schedule the application, to know about the worker node, all these things. This etcd is important. Etcd is actually a database. So the Kubernetes is one of the adopters of this etcd, and they are adopting this etcd for the purpose of storing the information. So this is a key value, like key value data store. So key value, in a sense, you have a key and you have a value. So that is how it stores. For example, if you have there'll be a OS. What is that OS? The OS, you have a core OS. So there you have architect. So architecture of the system. What is the architecture? Whether it is 64-bit or 32-bit. So like that, it is going to store that in a key value pair. So key value pair. So whenever that information is required, so we can query the etcd and we can get that information, and we can able to make some decision about the deployment in the application. So decision will be made by the API server. So for that, it requires an input. So that input will be provided by the etcd, and etcd itself will be running as a clustered database for the high availability. So it will be running as a clustered database, like in a master slave fashion. So it will be running in that fashion. And so this is, we can call the etcd itself, we can call this as a heart of the OpenShift cluster, because not OpenShift, can say Kubernetes cluster, because the etcd has the entire information about the cluster. So the etcd is down, that means the etcd database is not available. API server cannot make any decision. So because it is blind, it doesn't know which node is running, which node is down, what is the capacity of that node, what are the current application running over there, from which project is running. So all this information will not be there to the API server if the etcd is down. So etcd is very essential component. It is like a database which stores the entire cluster level information in a key value class. So the next important, and this etcd will also run as a containerized service. So this will be running as a static container. So we can say static pod. So this etcd itself will be running as a containerized service. And next thing, next important component is scheduler. So scheduler is one which manages the scheduling of the application. Like when you are giving an input to the API server, so to deploy some application, so your input come to the API server forwards your request to the scheduler. Scheduler will query the etcd. So what is the current availability of worker nodes? So what is the capacity in that? So the scheduler will get two inputs. So one input from the user side. So for example, I deploy the application. I say this application CPU is this much, and this requires this much memory and this much disk space, like that. So this is my input. The scheduler will take my input. On the other hand, it will take the input from the etcd to compare where it can place that application. So if your CPU requirement is this much, it cannot place in some node where the CPU requirement is not satisfied. So it has to compare your input and the available input from the cluster. It will compare this to where it can actually optimally place that application. It will decide, and then it will communicate to the node where it want to place that application. From there, it will be deployed in that particular node. So this scheduler will make that decision. So there is some algorithm behind this scheduler. Later on we'll study about that algorithm. So this scheduler is another important component in the master plane or control plane, you can say. Then the last component, which is important for managing the and this scheduler is also going to run as a containerized service. And the last one is controller manager. And this controller manager, the main function as the name indicates, it's going to do the continuous monitoring work. So as I told, it's an orchestration. So I may deploy some application. So application, I'll be scaling it. So that's the main purpose. One of the main principles or one of the requirement we are going for the orchestration is scaling. So I want to scale the application, and also I want to scale it efficiently. So if I scale it 100 times, if I modify one component, the 100 components, the 100 scaled application should should have reflected that particular modification. So that's what my requirement is. So that's why we are going for some orchestration tool like Kubernetes and OpenShift. And here, once you do the scaling, for example, I scaled it 100 times. So always that 100 numbers of application should be running in my cluster. So that is my desired value. So desired count is 100. So as a user, I want 100 application to be running. So that's my desired count. And maybe some reason during that operational time, some worker node may go down. So for example, I have 100 application, I have 100 worker nodes, and each application is deployed on each worker node, say for an idle condition. So that not be the case, but the idle condition, each worker node is having that 100 scale application on it. And for example, out of 100 nodes, so now I have 100 application, 100 scaled application. Out of 100, 5 nodes goes down. So due to some physical reasons, 5 nodes goes down, gets shut down, and my count now reduces to from 100. For example, 100 reduces to 95. So the current state is 95, and the required state is 100, or can say desired state is 100. So there is a mismatch. So what this controller manager will do, it will sense that mismatch, and once this mismatch is sensed, what it will do is it will recreate that 5 application which was shortage of the desired value in some other different worker node. So among that 95 worker nodes, it will create that 5 application which is shortage of the desired count, which is 100. So it will keep on doing something called a polling process. Polling process, in a sense, it's going to check your desired value as against the current value. If there is any mismatch between the desired value and the current value, if there is any mismatch with the desired value and the current value, so you will see that it's going to take action. So this is what the controller manager. We have different components of controller manager, like replica sets, replication controllers. So we have different components over there. So later on we'll discuss about that. So this is what the controller manager will do. So this is one of the important component of the master node. So these are the main important components. Not only this, we have a lot of components apart from this, but these are the core essential components for the entire operation of the Kubernetes. This is required. So I don't mean to say that only this is there, but apart from this, we have a lot of components for networking, for DNS, all these things. We have other components on authentication. Yeah. So we have a lot of components running over this. So we'll not have time to discuss all that components. So we are just discussing the core essential things, which will, for example, if this is absent, the entire cluster will not be functional. If any one of the components is absent in the cluster, so one of these 4 components, if any one is absent, the entire cluster cannot function. So that's the core components of this one. Core components of this master node, and all these things as run as a containerized service. And now we'll come back to the worker node. So what are the components are going to be there on the worker node, and how it's going to function. And the main function of the worker node is to hold, or you can have it's a place to accommodate the application or to run the application. The master node will have the responsibility of the master node is to do the orchestration, to do the control function, and the responsibility of worker node is to accommodate the application, to see that the containers are placed inside the worker node and the containers are running inside the worker node. So that is the responsibility of the worker node. To do that, we have something called a kubelet. So kubelet is an agent which will be interacting with something called, it will be interacted by the scheduler. The scheduler will give a signal to start the container deployment. Once the scheduler decides to place the application on this node, it will communicate to the kubelet, and kubelet, what it will do is it will communicate to something called container runtime. So container runtime, you can say container runtime engine. So we have a lot of different tools available, supported on the Kubernetes. Here inside the OpenShift, so we are going for a tool called CRYO. So CRYO stands for Container Runtime Interface, CRI, and O stands for Open Container Initiative. So this is like a pretty much substitute for Docker. So previously the Kubernetes was using the Docker. Now the Docker is not used because of some vulnerabilities with that tool, and also Docker is like a heavyweight tool. So this they are now opting for something called CRYO. So this will actually, what it will do is it is going to build the container. So it's a container runtime engine. So it's going to build the container. So previously this work was done by the Docker. Docker is now not there in the recent version of Kubernetes due to some vulnerabilities over there. But at open source, you can adopt any tool. So it's when you do the OpenShift, when you do the Kubernetes installation as an open source, you have the choice to use Docker, you have the choice to use CRI-O or Containerd, some different tools you can have option. But here, since this is a standard tool, like OpenShift is a standard tool, so we need to use only the CRI-O. So because we don't have a choice, because we will be installing the OpenShift as in a very high level perspective, automatically that will install the CRI-O. So we will not have any choice to change this tool. But when you take the Kubernetes as an open source, you have the choice to go for whatever the tools you want. Either you can use Containerd or CRI-O or Drawbridge. Different tools are there, so you can use even Docker. But here we have to mandatorily use the CRI-O. So this CRI-O what it will do is it's going to build the container. And how it is going to build the container? So it is going to build the container through the pod. So we have something called a pod. Pod is a basic unit of Kubernetes, where the pod definition involves like a collection of containers. So it's called a pod. Like I may have even one container, that is also you can call this as a pod, or you can have multiple. I can have 3 containers inside a pod. So collection of containers of pod. And why we have this wrapping element, the pod is just for the management function, to manage the containers in an efficient way, to manage the multi-container deployment in an efficient way. So we have something concept called pod. So pod is nothing but collection of container. The pod will hold a container inside it. So the container may be a single container, or it may be multiple containers. So whatever the case is, the collection of containers of pod. So we will be dealing with mostly with the unit called pod. So pod will be the atomic unit of Kubernetes. So we'll not be directly saying that container running. So even though container is running inside the pod, we'll be telling that pod is running. So we have to say the status of the pod, whether the pod is running and not running. We'll call that as. But in turn, the pod, whenever I say pod is running, that collectively means containers inside that pod is running actually. So if it is having one container, so that one container is running inside the pod. If you have multiple containers, the multiple containers running inside the pod. So we'll be dealing with this pod unit. So pod is not nothing but a collection of containers. So this CRI-O the kubelet will interact with this one, and it is going to build that pod. And later on, there is a communication agent. So we call that as kube proxy. So the function of kube proxy is to enable the communication means. So we have a lot of communication requirement, like communication channels are required. For example, a channel is required between the master node and the worker node, and a channel is required between the scaled application. So I have 100 applications scaled. So this 100 application will be on different worker node. There should be a channel to for this 100 application to communicate to each other. So there is a channel required. There is a communication mean requirement, and also there is a requirement for the user to communicate to the in some cases to the worker node. So how this is fulfilled is through the agent called kube proxy. This is a network agent which will take care of communication between the containers running inside the worker node, among the worker node, between the master node and the worker node. All this will be taken care by this kube proxy. So that is the network agent which will take care of that. That is also going to run as a containerized service inside this. And all these things like kubelet, CRI-O, kube proxy, everything will run as a systemd service. So as a daemon service inside the worker node. It will not run as a container. It's not a container. So unless unlike this API server etcd, which is running as actually a containerized service, here this kubelet, kube proxy, CRI-O, all these things, all this unit will be a systemd unit on the worker node, which will be running as a systemd service. So we have to take care of that difference. And this kubelet and kube proxy will also be there in the master node for some function to create this API server, because this is a container. To create this container, I need to have a kubelet over in the master node also. So, but I'm not explicitly mentioning that, because we are discussing from a functional way. So the master node will have these things, these functions are important, but the kubelet and kube proxy will also be there in the master node as well. Okay, so this is the basic architecture of Kubernetes. Any doubts up to this? So I'll get back to the. So whatever I discussed, I'll just get back to the slide and I'll explain you there. So any doubts about this?
No.
Okay. So whatever we discussed, so this is a Kubernetes architecture. We have a Kubernetes master, so we have this services like API server, scheduler, controller manager, etcd, and all these things. And this controls the worker node. So worker node will have pod. The pod will hold the container. So to build this pod, I have CRI-O. To signal that signal that requirement from the worker node, from the master node, I have kubelet agent. So that will fetch the input from the master node. This agent will communicate to the CRI-O, and CRI-O is going to build this, going to build the container inside the pod. It will first build the wrapping element pod. Inside that is going to build that container, and the kube proxy will be responsible for the network communication among the different worker nodes and the master nodes, all these things. So this kube proxy element will be there. That to interact with this Kubernetes master, so we'll be using something called kubectl. But here in the OpenShift, we'll not be using kubectl, but as a directly, because we are dealing with the Kubernetes architecture directly, so we can use this to interact with the Kubernetes using the kubectl. But we'll be using something called OC command. So later on we'll see about that. What is OpenShift command? Okay. I hope now this things are clear. Since our discussion is about the architecture of OpenShift, not about the architecture of Kubernetes, but since the Kubernetes is it's a core of the OpenShift, so some of you may be new to the Kubernetes, so that I discussed this point. But our point is to discuss about the OpenShift architecture. So what is the architecture of OpenShift? That's what we want to discuss. So I can simply say that OpenShift is having Kubernetes, and I can go on from there. But some of you may be new to the Kubernetes, so that I just explained that architecture in detail about how the Kubernetes architecture works, because we are going to deal with these terms again. So we are going to use these terminologies. We are going to say the worker node, where there it is going to the application is going to get deployed over there, and is like this. So what is kubelet and what is CRI-O? So with these terms, we are going to utilize, or we're going to use it again and again, so that we need to have the core understanding of the Kubernetes. So now we'll understand about the OpenShift architecture. So OpenShift architecture, the OpenShift can be installed on any infrastructure, whether say it's a physical, virtual, private, or public cloud. So it is going to have a container host. You can say the Red Hat Enterprise Linux Core OS, and on top of that we have something called Kubernetes. So we have discussed about this Kubernetes architecture, and there is something called operator. So like I'll go to this again. So I'll open a new thing. Right. So here we already discussed about the Kubernetes. Is the core of the OpenShift architecture, and over this Kubernetes, we are going to have something called operators. We call this Kubernetes operators. So we'll come back to this, what is an operator, and the next chapter. So next section. So we are going to see about that. The next section is about the operators only. So we'll discuss about this operator. In a short, I can say operator is a automated software manager for the Kubernetes, or you can say the Kubernetes resources. So the operator is something like an automated manager. You can say automation to the next level, or intelligent way of automating the resource. So that's what an operator is going to do. Or can say it is an extensibility component. So what is not there in the cluster natively. So how you are going to extend that functionalities, so that is through the operator. So that is there, that is a core of this one. And on top of that, I'm going to have the OpenShift. So OpenShift components. So we have the OpenShift, we call this as OpenShift cluster. So this OpenShift cluster has to have a means. So how the user is, as a user, how I'm going to communicate to this cluster. So there is something called OAuth. So OAuth is something which is an API authentication mechanism. So OAuth OpenShift. So as a user, what you will be doing is you will be communicating to this OAuth OpenShift. Then your request will go to the there will be a separate OpenShift API server. So your request will actually go to this OpenShift API server. So your request will go to this OpenShift API server. Then the request will reach the Kubernetes API server, and then it will communicate to the master, the worker, that normal function will be happening over here. So this is going to have the API server. This request will be going to this, and this will be, your request will be actually here, it will go to there. So this is called a proxying request. So your request will be proxied. So actually it reaches the API server of the OpenShift, and the request is actually proxied, and actual agent who carries out your request is a KubeAPI server. Inside this, it is going to be everything that's a Kubernetes thing. So, but as a user, we'll be communicating through the OpenShift. So this is the main architecture we have to remember. So underneath that we have the Kubernetes. So we have the operator concept. So we'll discuss about the operator later on. And this is how your things will get going with this one. So whatever the request which is you are getting back, and also whatever the request you are giving as input, that will be proxied to this server. So your request will be going in a bidirectional way through this OpenShift API server. So, and what this OpenShift is actually offering, so we have the operators. On top of that, I have the OpenShift. So OpenShift is offering me these things, like, which is not available as a default thing on the Kubernetes. So OpenShift is providing me the cluster service, like monitoring. So there are a lot of plenty of tools available, like Prometheus, Grafana. So these tools are supported inside the OpenShift. So using which you can monitoring, because monitoring is very essential in any platform. So there is a default support to this one, and there is a something like application service. So we have service mesh. So for the application level deployments, so we have this service provided by the OpenShift, and we have the developer service, which is like doing the CI/CD kind of things. Like we have direct support to the Jenkins, Tekton, like that. So we have direct support to that. So this is what the OpenShift is provisioning. And if you ask me why, so why a user should go, or why a customer should go for the OpenShift rather than, because when you consider the Kubernetes itself, that's a very good tool actually. So Kubernetes itself, you can directly use it and you can get the best out of it. And why a customer, a client will need to go for the OpenShift. So what are the requirements? So to answer that question, so I'll come back to this slide. So to know why I need to use OpenShift than the Kubernetes, the answer is that so Red Hat OpenShift is a secure enterprise grade container application platform, which is based on Kubernetes for traditional and CNA application, like cloud native applications. And so OpenShift is specifically designed to bring the developers and operation teams together. So to have some kind of an environment where both the peoples will work in a ease. So there are shared responsibility between the two kinds of peoples, like DevOps and so Dev and the operational peoples. And when you consider the Kubernetes itself, so it is a very good tool. It's an open source system, so it is useful for automating the deployment and the scaling, all these things. It's a very good tool for doing that. And Kubernetes does a lot for us. So the basic orchestration, deployment, networking, scaling, all these things are done by the Kubernetes. So underneath, we'll talk about, we are dealing with the OpenShift, but underneath it we have the Kubernetes which is doing all these things. So that is that's a lot for a user. So I say this, Kubernetes is you can use it as an entire independent tool. So without the OpenShift also you can use it. And there are some problem with the Kubernetes. So that the problem is like, one is security issues. So some customers, clients have given this comments over the Kubernetes with respect to the security issues. Other thing is Kubernetes does not do these things out of box. So I don't want to say that Kubernetes will not able to do it, but Kubernetes directly can do it, but that will not be available as a out of box experience. So for example, the multi-tenancy concept, it is not there in the Kubernetes, but you can implement that concept in the Kubernetes, but that is not a mandatory requirement. But in the OpenShift, the multi-tenancy is mandatory. Like we have to create through something through the projects. So we have some concept called projects. Through the projects, we'll be able to manage the application. So that is there in the OpenShift. That is an out-of-box experience. So we have something called self-service. So in the OpenShift, we have the web console. So where you can do your job independently, and it's very easy to do that. And it's a self-service. Like you can easily learn about this different things in the web console. So there is the OpenShift offers. Kubernetes offers a web console, but that is not as rich as the OpenShift. So OpenShift web console is very it has got a lot of tools to help you, the user, to get going with the cluster operation. So like this, you can have a lot of things like dynamic storage, quota management, all these things you can do it, which is actually an enterprise requirement. Any enterprise product needs these things. So that the user may not be concerned with configuring these things or worried about configuring these things. So this is what the OpenShift is doing. So if you want to give a term for all these things, so I'm not discussing all the points. The time may not be sufficient to do all these things. We'll see this later on as we are going to work around the OpenShift. You can substitute a name for this. This is called enterprise capability. So this enterprise capability is not there in the Kubernetes by default. So you have to note the word default. Means it is available. So for that you have to do some configuration changes and managements to get that things. But this is there in the OpenShift by default. So OpenShift is just as an enterprise tool. So you can just have the OpenShift installed and start working towards your goal. So you need not worry about the security issues. You need not worry about the management issues, or you cannot constraint issues. So all these things are provided as a tool for the user to work on. And this is the overall picture now. So on one side we have container, another side we have infrastructure. So we have the platform, so where we are going to establish. So in between that we have the OpenShift. So together with the power of the Kubernetes, the OpenShift is provisioning this with this enterprise capability. So we have a complete tool which is going to provision the user enterprise level deployment or application management tool. So the OpenShift is adopting the Kubernetes, and it is provisioning an additional things over the Kubernetes. But Kubernetes is there underneath the OpenShift. So additional things which is not directly available in the Kubernetes is being provisioned by the OpenShift. So that's the reason why a client or customer needs to prefer the OpenShift when it comes to the enterprise or production environment. So if it is a non-prod environment, that is a different case. You can go for a lot of tools are available. So you can, if it's a non-prod, a testing environment, a quality analysis environment, so that is a different case. But when it comes to production and production environment, or can say enterprise level deployments, a client will prefer need to prefer this, because that's where this you have a, for example, you have certified images available, certified things are available inside the OpenShift, so that you have the vulnerability analysis. So that whatever the deployments you're doing, that is secure. So whatever your clients are there, so they will be satisfied with your working, or satisfied with your deployment. So when it is open source, the things get the works get doubled. Like you have to first configure the things, then you have to verify that is it certified or not, and you have to analyze this thing by the tool. So work gets very like lengthier than the deployment you're doing in the OpenShift. So that's the reason why a customer is going to prefer, or how you can satisfy a customer to use OpenShift rather than using the Kubernetes directly. So after that, So we'll come back to the discussion. Okay, so we are done with this one. We have just discussed one point here. So we are discussing about the introduction to the control plane. In the book, you can find the architecture of OpenShift control plane. They are discussing about so one master itself. They have covered all the points. Like they are saying that so here itself. So one master node they've taken as an example. So here they have seen that Kube API server, the controller manager, kubescale, etcd, kubelets, all these things. So whatever the blue point, this is a static pod. Static pod means the pod which is not a control pod. So this is a main pod where you cannot do any modification over this. This is a core pod. So this is a static pod. This is itself running as a containerized service, as I told. So that is it considers a static pod. Here in the OpenShift, this is called a regular pod. The OpenShift API server, these things are called regular pods. So even though this is running as a containerized service, we call this a regular pod because we need to modify some things. Like we need to modify according to our requirement. So whatever the requirement is there, so we'll be modifying. That's why we call this a regular pod. Even though this is also a containerized service. So whenever the request reaches the OpenShift auth, so this reaches the OpenShift API server, your requests are proxied to this Kube API server, and this request gets converted over there. There is the actual things that are happening over there. So we have the OpenShift also have a separate controller manager, and it is having a DNS. So later on we'll discuss about this DNS. What's the purpose of this DNS? So this is deployed as a regular pod, and there are systemd service, this kubelet and cryo. So that is all you can see here on the legend. You can see there's a systemd service. So this is where there. So you can so in the book it's very simple because they assume that you know about the Kubernetes. So here you can go through this one. It's a very simplified picture, or you can go through this. This is where you can have some detailed understanding of what are the different components, how it is working over there. And now I'll come back to this, the declarative architecture of Kubernetes. I'll come back to this point. What is the declarative architecture of Kubernetes? So why we need to go for this declarative architecture? What is the purpose for this? Declarative architecture, you can compare, for example, you can compare that with how you do the normal system administration task. So for example, I want to add some users. So in a server, I'm now talking about server level. I want to add some users. So one way is like, one minute. So you want to add, say my task is to add 2 users and set a password for the 2 users. So at the server level, I can do this very simply with the command. Like I can use user add command, and I add 2 users, and I'm set. So it's easy to add 2 users, and I am set the password for the 2 users. That's fine. So this is called something called imperative architecture. So imperative architecture. So where I execute the things with the command line. So whatever my request is there, so I'm just executing that thing in the command line. That's the imperative architecture. There is another architecture where the requirement, for example, now I want to add this 2 user. That is very easy. But in case I want to add 100 users, I want to add 100 or 200 users to the server. So how you can do it? I cannot use the user add command and do that task. Even I can do that, but that is a tedious one. So I have to go for some other option, like I have to use a script. So I'll write a bash script or Python script to take care of this function. So adding 100 users, it will get your input from a file. Take the input, and it will create the so you will write some logic in the script to do this job. And the second nature, so what I'm discussing, second is called this declarative. So whatever your input, you are declaring in the file, and you are executing that declarative input, or you can say declarative definition. You're executing that, then that is executed as a part of that logic, whatever given. So depending on the logic, it's going to create that. So this is what a declarative architecture. So what is the benefit of declarative and the imperative architecture? So declarative architecture is beneficial in a sense. I can replicate. So first benefit is I have a documentation. So I have the script file. So I can replicate my work in other server also. So just I change any inputs or change the input to the file input or something. Same thing, I can replicate it back on some other server. I have a documentation. I can do a customization. How I want to get the input, how I want to manage the input, I have that customization option is available in the declarative architecture, whereas in the imperative architecture, I don't have that. And I have a backup in case something happened to my server. If I want to, if some server is down for some reason or server got corrupted or something, I can repeat this back with the file. So I can place that file in some other different location. From that, I can fetch that file back and I can do the same function. So it's a matter of fraction of a second, I can do this things so easily. So I have a backup for that. These are the benefits of declarative architecture. The main thing is customization, documentation, as well as a backup. So these are the benefits of declarative architecture. And imperative architecture don't have that. Imperative, it can just be used for the time being. So I can execute some commands, I can have that things. But I cannot do the customization. Even if I do the customization, I have to remember a lengthier command to do that customization. And I don't have a backup. So I just did it on the terminal. Once the terminal is cleared or something, I don't have the backup. I don't have any means to provide documentation. So the imperative architecture is not preferred much in case when you want to do something at a very scaled level. So we'll be always preparing the declarative architecture. So this is what we are doing at the Kubernetes. So Kubernetes, any input, any resource you want to create. So whether it is a container, pod, or something. So you will declare your input in a form of a file. So here I have shown here a sample file. So where you can see so something like which is called deployment later on we'll see. So I am deploying, I can use this is my input file, this is my declarative architecture, or declaring my input in the deployment file. So through this file I can create this resources. So I have a definition for the replica set, I have the definition for something called pod, I have a definition for the container. So whatever this color indicates, the definition for that resource. So I'm just getting that definition over here, and so this will create that resource. Once I have the deployment in place, this will create the replica set, pod, and everything. So whatever my request, what are my things, inputs, and everything, I'm just putting it that in a file. Through that file, I'm creating that resource, or creating that kind of things. And how to write this file? So that will be the Kubernetes scope. So if you have studied the Kubernetes course, you will know how to write this file. So you know what the terminologies to use. But here we are going to at the operation level, we are not going to in depth about writing this file. So we are going to use the file. So we are going to do some kind of modifications. Already the file will be there. We'll modify that file to suit our need. But anyhow, so we'll be using this kind of things to declare my input. So I'll be having this kind of files. I can have independent definition also. I can separately create a pod, separately create a replica set, but I can create through the deployment. So deployment, later on we'll see about the function of each. So what is deployment, what is replica set, later on we'll understand about that. But now we'll see, just showing you a sample example, how the declarative architecture works in the Kubernetes. So this is a sample file through which you can create the resources. So this is what declarative architecture is. Then we'll discuss about the Openshift extensions. So what is the extensions? So extensions are the way to bring some resources which is not natively available. For example, natively available in a sense. So we need the options, like for example, if we take authentication into the Openshift. So if we take authentication, the Openshift supports 8 different authentications, so 8 different authentication elements. Like it supports basically LDAP, it supports Keystone, so it supports like Google, the Google authentication factor. So it supports a lot of like this. So how to use this? For example, I want to use a Google. How can I use that? This is through the extension. You can call this as a plugin. So you can call the authentication plugin. So if I want to use Google, I have to have a Google extension, or I have to configure the Google extension into my Openshift. So that's all. So we'll have the Google authentication available in the Openshift. If I want to use Keystone, I get the Keystone authentication. So this is an example with respect to the authentication. So for example, if I want to storage, Openshift supports a lot of storage things. So storage things. For example, if I want to use Cluster storage. So it's simple, just you have the clusterfs plugins, get the clusterfs plugin, configure that plugin into the OpenShift so that it is going to start using the clusterfs storage. So apart from the clusterfs, it supports Chef storage, dynamic storage, cloud-based storage, and all these things are supported inside the OpenShift. So any storage if you want to use, have that plugin of the storage configured inside. There are documentation to see how to configure that. See that, look into that documentation and configure that plugin into that, or you can say extensions into that OpenShift. So it's going to start using that plugin. Through that plugin, we can able to interface with that storage and utilize that storage for the OpenShift. So these are two examples for how you can use the extensions. So OpenShift supports a lot of extensions through which something which is not natively available in the OpenShift. By default, it's not available, but you can get that functions. You can get that things into the OpenShift through the extensions, or you can call that as a plugins. So this is what OpenShift extension. And last thing to discuss is about default storage class. We can say what is a storage class. Storage class is a means of how you classify the storage. So when it comes to storage, we have different provisioning system in the storage and different requirement in the storage. Like for example, if I have a database system, for the database system, I need to have provide some storage which is having high speed access. So we normally measure the storage with the high IOPS, input output per second. So I'll be measuring with that. So for the database access, for the database system to access the storage should have a high IOPS, so input output rate per second. So that should be very high. So for the normal system, like I'm storing some log information or monitoring information, for that the high speed access is not required. I can just go and do that storage on a normal like hard disks or normal storage system. Normal retrieve time is sufficient. So it doesn't require high IOPS. So in that way, I can classify my storage. So it's whether it is a high speed storage or it's a normal speed storage, or I can even get some storage from cloud. So it's a dynamic storage, or I can get a software defined storage like Chef. So like that, we have different classification of storage. How you are going to classify the storage? So that is what a storage class is, and storage class will have a driver. So you will define a driver how to access that storage. You will be defining the later on. We'll understand about what is a storage class. So here the storage class is a means of classification. So means of classifying your storage, or means of specifying your storage thing is through the storage class. So later on we'll see there is one section dedicated to the storage management. So there we'll understand how this storage is going to work. Okay, so with that we complete this section. So we have seen 4 different things about architecture of OpenShift. Then we have seen about what is a declarative architecture. Then we have just seen about OpenShift extensions. What is an extension is. Then we have discussed about the storage class. What is a storage classes? And following this, there is a quiz. So here I'll do 2 quiz. What you can do is you give a reading of this section. So you give a complete reading of this page. So I think this only 2 pages are there. So 2 to 3 pages. So just give a reading of this page. Then try to attempt this quiz on your own. So here I'll try to do 2 quiz out of I think 5. So there is a solution at the back also. So you can try to do this on your own. In case if you want to know what is the solution, you can go back and look into the solution in case if you are not getting it right, or we can discuss later on any doubts there on this. So here I'll just do, for example, I'll just do 2 quiz here. Later on you can do the other quizzes. So here the first quiz is OpenShift is based on which of the following orchestration technology. So this is based on the Kubernetes. So it's not based on these technologies, it's completely based on Kubernetes. And which 2 of the following statements are true of OpenShift container platform? OpenShift provides an authentication OAuth server that authenticates calls to REST API. That is true. So OAuth server is there. We already discussed that during the architecture. We can see the OpenShift OAuth server. So this is giving the access to the API. So the API type is REST API. So we have 2 types of API, REST and SOAP. Mostly now all the APIs are mostly REST API. And OpenShift requires cryo container engine. So this is true because OpenShift we have already discussed in the architecture. So we are using the cryo engine to build the containers. So this is true. And Kubernetes follows a declarative architecture, but OpenShift follows more traditional imperative architecture. So this is not true, because OpenShift and the Kubernetes are going to be like one and the same. So whatever the Kubernetes is following, that is mandatory to be followed by the OpenShift. So OpenShift doesn't follow in different way. So this is not true. So this is false. And the last thing, OpenShift extension APIs runs as a system service. So this doesn't run as a system service. This runs as a containerized service. We already seen that during the thing. So whatever the extension and all these things runs as a containerized service. So it's not running as a system service. So this is not true. So these two things are not true. Only these two things are correct answer. So you can refer back to the solution at the back. So you can go through this. And now we'll start with the any doubts to this. So we have completed one section, so which is about describing the architecture of OpenShift. So we have covered different points. So how the OpenShift architecture is working. And now I'll come to the next section. So the first chapter. So I am skipping this first section to the skipping in a sense. I will be swapping this to the last day. I'll be discussing about that. And the second section we have completed. Now I'll move back to the third session, which is about cluster operators. I'll be discussing about this now. So we'll have a break, short break. If you have any doubts, we'll discuss that. Now the time is 11:20. So we can have 15 minutes of break. By 11:35, we can start back the next session. Now it's 11:20. 11:35 will start the next section. So discussion. So if you have any doubts in between, you can just put in the chat also. So we will start back by 11:35.